Greetings, Benjamin J from BENZTRAINZ with another in the series. Well, a follow-up on that Lionel General with a DC motor. And I was going to add a diode to the motor, but this is a much better motor than that little switcher engine. So it chattered using a single diode. So I'm going to use a full-wave bridge rectifier, which has just arrived. So this is a full-wave bridge rectifier. And basically it's 4 diodes mounted in a box. That's really all it is. So I've got my lock on the rail for the Lionel, and I'm going to connect this directly to AC just to show that it will not run on AC. As you see, it just sits there and buzzes, and you will burn the motor up if you try to run it on AC. So what I've done is taken the rectifier and added 2 wires, hooked it to the transformer, and notice 2 of them are unmarked, 2 of them are positive and negative. So AC, it doesn't matter, there's no polarity for AC, so you can put the AC power in either position. And then we'll take our lock on and clip one side to negative and clip the other side to positive, and as you see, the locomotive is up and running with plenty of power. So running a DC locomotive on AC simply by using a full wave bridge rectifier. So it works absolutely perfectly. So I'll mount this rectifier someplace, very likely under that motor. There's lots of room in that cab where that motor is mounted. And mount this directly in the locomotive, and from then on it is a straight AC locomotive. So a really simple way to do this. 4 wires, 2 coming from the AC and 2 supplying DC. So this works. It works really well. Total cost $3. So I'll pull this apart. Like I said, I will very likely mount, you can see the motor in there, I will very likely mount the rectifier underneath that motor. That way it'll be invisible. And I run the 2 DC wires directly to the motor. The pickup runs directly to the rectifier. Put it back together, and from then on it is an AC locomotive. It'll run on AC forever. So anyway, I just want to do a quick follow-up on powering DC locomotives. Like I said, don't be afraid to buy these things. I found this thing for 40 bucks. That's quite inexpensive for a Lionel General. If this was an AC locomotive, it would be 2 to 3 times that price, very likely. Anyway, 40 bucks for the locomotive and the tender. It was DC only, so nobody wanted it. And so just as you see, by adding this simple rectifier, the locomotive is up and running on standard AC track. Excuse me. It'll now run on any track on the layout. So it's simple, it's inexpensive, 3 bucks. It'll take a grand total of probably 20 minutes to install that rectifier. I just got to pull the cab off, find a place to mount it. I'll very likely mount it with double stick tape. Wire it to the motor, and from then on, this is a standard AC locomotive. You can see that's running just absolutely perfectly on AC using a simple $3 rectifier. Really simple to do this. Like I said, I could run it on a single diode, but this is a much better motor than was in that little tank locomotive. So using a single diode, it chattered. I wanted to run nice and smooth, so I went with a full wave bridge rectifier. Now I could have just made a full wave rectifier out of 4 diodes, but like I said, I was completely out of diodes. When I went to order them, the diodes are 2 bucks. This rectifier is 3 bucks, and I didn't have to do anything to it except order it. So I went ahead and ordered the rectifier itself. Like I said, I'll mount this very likely under the motor in the cab, and from then on we have a standard AC locomotive. Now as you see, that's running absolutely splendidly on standard AC power now. So very likely later today, tomorrow, I will pull this locomotive apart I'm sure there's lots of room in there. That's just a big empty cab. It has the motor mounted right there, so I would imagine there's lots of space to mount this rectifier. So anyway, I just want to do a quick follow-up. Like I said, these DC locomotives, you can get them cheap. In this case, I got it for 40 bucks because nobody wanted it because it's a DC. So I ran it on DC for a couple days until the rectifier showed up. You see, it only takes 4 wires. AC goes to these 2 terminals. DC comes off of these 2 terminals. It's really, really simple. Full wave bridge rectifier, 3 bucks, and this locomotive is up and running absolutely splendidly, as you can see. Running on standard AC power now. So like I said, I'll pull it apart. I will mount that rectifier in the cab, very likely with a piece of double stick tape, wire it to the motor, and from then on, this locomotive is a straight AC locomotive and will run on any standard AC layout. So really, really simple way to do this. 3 bucks total cost. Went ahead and bought 2 of them in case I come across another DC locomotive. But it's simple, it's really inexpensive, and it's really, really easy. So 3 bucks. It'll take about 20 minutes to get this mounted, and from then on, it's an AC locomotive. So anyway, just to follow up on this, these full wave bridge rectifiers, 3 bucks on eBay. Really difficult to beat that. Like I said, there's lots of room in there, so I'll either mount it in front of the motor, under the motor, behind the motor, on top of the motor. Lots of space in that cab. It just depends on what's the easiest way to run the wires. So I'll get this converted, and from then on, it runs on standard AC track power. So I just want to do a quick follow-up video of these full wave bridge rectifiers. You can make one out of 4 diodes, or in this case, you can just buy the completed thing for 3 bucks. That's pretty cheap. Easy to do, 4 wires, and it'll convert any DC locomotive to run on straight AC. So anyway, just a quick video. As always, if you have any questions, feel free to drop me an email, BENZTRAINZ@gmail.com. And as always, thank you for watching.